Hello, welcome back to CIS 2353. This is week 3. We're going to be discussing chapter 4, which is the Java Collections Framework. So what is a collection? A collection is an object that is composed of individual elements. For example, an array, which we've seen multiple times before, is a collection. In this example, we're creating an array of double values. You use the keyword double, which tells the compiler what is the data type that we want to store in the array, and to determine if it's an array or not, we have to use the brackets. The brackets indicate that it is an array. If you did not use the brackets, this would be a single double value, which is a primitive. You then say equals new double and then the size. The size that's passed here can be an integer literal, an integer variable, or an integer constant. And it can be determined at runtime. So right here, when we say double brackets salaries, this part right here does not create an array object. All this does is create a reference variable that can hold the memory address of an array object. And by memory address, when dealing with arrays, we're talking about the address of the first element in the array, since arrays are stored contiguously. So contiguous just means adjacent. For these 1,000 memory addresses, through the JVM, they are treated as if they are adjacent. So, and you can do simple arithmetic to get to the different indices of the array, because all you have to do is know the size of a double, which is 8 bytes in Java, and then you just multiply by whatever index you're trying to go to get to the, and then add to the beginning array address to get to the next index. So it's very convenient in some ways. It's very fast to access elements in an array. The elements in the array object, referenced by salaries, are stored contiguously so that the kth element is at index k. So the array object is actually created with new double 1000. So keep that in mind. An array is a random access storage structure. That means that any element can be accessed immediately from its index. It doesn't matter if you're trying to get index 500 or index 5000. If the array is large enough, as long as it's a valid index, you can access it directly by just giving the index itself, and then the array will figure out what's at that index. That's because of the contiguous characteristics of an array. So this is not the case with other types of structure like linked structures. It's more difficult to access certain elements at the middle. Drawbacks to an array. Once created, an array's size is fixed. If it's too big, then you have a bunch of unused space. If it's too small, what do? Well, if it's too small, you would have to create a new array and then copy all the elements over. So you're actually wasting a lot of time every time. So for example, if salaries, which is 1,000 double values, is too small, let's do the example here. We have to create a variable, say new salaries, set it to equal to new double, and then double the size. And then you have to actually call an array copy. You have the array you're copying from, the beginning index of that array, the array you're copying to, the beginning index of that array, and then the length of the, or how many elements you want to copy over. So we're copying the 1,000 elements from salaries into this new salaries variable. So finally, you're going to say salaries equals new salaries. Now, that does not, this in and of itself, as you should have learned in your 1500 probably, and definitely your 2151, and if you haven't, this should be a good review. If I just have two arrays and I just immediately say salaries equals new salaries, or salaries 1 equals salaries 2, this does not copy all the elements over. Remember, we are not dealing with primitive data. We're dealing with arrays. Arrays in any kind of object are non-primitive. They are objects. They are reference. They use reference variables to refer to them. The primitive types in Java, there are 8 of them. Remember, you have the byte, you've got short, int, long, float, double, boolean, and char. So you've only got 8 primitive types. Those are the only variable types in Java that hold the data directly. The other types, including arrays, and any object you create from scratch, say if you have a person object or a person class you create objects from, or a cow class or what have you, bank class, bank account class, you always have to allocate the memory dynamically. Therefore, you use the new keyword. So that means the memory for these objects are allocated at runtime instead of compile time, as is the case with primitive variables, the 8 that I mentioned. So, what is stored in a reference type variable? Salaries is a reference type variable, so is new salaries. Whenever you perform an assignment operation, what it directly does is it copies the contents of new salaries into salaries. Well, remember, the contents of new salaries is not the array object. Now that may seem confusing because we access the array object through the array variable names, just like you access methods and data through any object name. However, you have to remember this reference variable, these reference variables, are not the objects themselves. They only contain a memory address. So what you're doing here is you're copying over the memory address. So if you would not have called array copy and you just had 2 different arrays, you were copying one into the other, that only copies the memory address. So the effect would be that you just have 2 different reference variables holding the same memory address. If you modify one, it changes what the other accesses because they're both dealing with the exact same object. At the end of the execution of this method, what happens to the reference new salaries? Well, new salaries is going to die. It gets returned. It's garbage collected, because salaries is what we really wanted to set. So what happens to the array object of 1,000 double values that salaries formerly referenced? That array object that existed before is also marked for garbage collection. We've copied the data over. We're ready to go with our new large array, but it did take time. If you were to look at the way the copying occurs, you'd probably find that we have a big O of n operation. So every time you need to expand, you have to go through and you have to copy over every single element one by one. Because in that case, you're actually copying the data. So drawbacks to an array. The programmer must do all the work to maintain and utilize the array. Well, that's a problem, right? Because you have to perform the accesses and do all kinds of crazy stuff sometimes. You have to do all the work. For example, let's say we want to insert an element at index 30 without overwriting the element currently at index 30. For example, if there's a 50 there, we don't want to actually change that value. We just want to insert a new element there. In order to do that, you have to move all the subsequent elements up if there's room. So that means you have to do a copy. You basically start at the end, one outside the current number of elements, and then you have to keep moving them up one by one until you make room for this 30, and then you insert the 30. To print out all the elements, you have to keep track of how many there are, not simply salaries.length. Think about what this means. If you make an extra large array that is larger than the number of items you actually have or keep in the array, you have to manage some variable that keeps track of how many elements are actually valid in the array. Salaries.length gives you the number of cells in the array. In other words, the number of, essentially the number of valid indices. Okay? The highest index being length minus 1, of course. So what's better than arrays? We have instances of collection classes. Okay, so now we're going to deal with collection classes, which come from the Java Collection framework. The Java Collections framework contains these collection classes, which are classes whose instances are collections. Okay, pretty simple, pretty straightforward. The elements in an instance of a collection class must be references to objects. Okay, that's very important because you cannot directly create, for example, an array list of int type or an array list of double type, lowercase d. You can't do that because they all need references to objects. So how do we get around that? Since the primitive type, int, double, boolean, short, byte, etc., they are not allowed, every one of them in Java has a corresponding wrapper class, W-R-A-P-P-E-R. So these wrapper classes can be used. So integer with a capital I, double, Boolean. So everyone except for integer and character are just the name of the primitive type capitalized. Int has corresponding integer, char has corresponding character capitalized. So keep that in mind. But the others like double, Boolean, float, etc., they all have their variable name but with a capital. That's the wrapper class. You can also use types that are already non-primitive, such as string, full-time employee, cow, horse, donkey, whatever you create or have created for you. A contiguous collection class is one of the types. They work very similarly to an array because behind the scenes they're storing the elements in an array field. Now remember what field means. When I say the term field, you should automatically think it's a data member or a member, often private, that lives inside of the class. And when you create an object, they each get a copy of their own fields. So when I create a contiguous collection class object, there's an array field that is working behind the scenes. Now we, as the users of these contiguous collection classes, do not directly access this array field. The class itself manages them, so we don't have to worry about it. So, prior to Java 5, the collection classes basically used object as the type that they could contain. So you did not specify what type these, for example, an array list would hold. That may seem really useful because using polymorphism, we know that we can put any data type essentially inside of the array list if it holds objects. However, there are drawbacks. Let's say you want to make an array list of products for a cash register application or something, or a barcode scanning application. If you have an array list of products, you, without generics, prior to Java 5, you would have to use the regular old array list, which basically did not let you specify what type, so it would hold objects. So that means it can hold anything, but you can't guarantee that all of the items in it are products. The other problem is that when you get elements out of the array list, you have to cast them to the proper type before you can use them. So these are drawbacks. So at Java 5, they came up with generics, the use of type parameters in declaration of classes and interfaces. Just like functions take parameters, you can use type parameters with various collection classes and anything that is a generic. So in this case, we have the declaration of the new array list. It has an E as just a placeholder. E stands for element. That's a type parameter. Now, type parameters go within angle brackets. Okay, angle brackets. So those are the less than, then you put the type, and then the greater than symbol. So it's similar in some ways to the ways that we have parameters in method definitions, but these are called type parameters. When an instance of the array class is declared or initialized, a specific type in angle brackets follows the class identifier. For example, let's say we want to create an array list of doubles, named salary list. Now, as I said before, you cannot just say array list and then put double with a lowercase d. You're going to get a compiler error. In fact, we can check this out over here. I've created a package for week 3. I'm going to create a class, and I'll call this array list test. All right, so we've got our code. In order to use ArrayList, the Java Collections framework live inside java.util along with a lot of other stuff. So I'm going to say import java.util.ArrayList. Okay. When you import it, you don't need the type parameter. However, when I create the main method, fill it out here, right, in class. When I create this, I'm going to create an array list of, for example, strings. I have to provide the type there. And then when I say, well, we'll do double just to keep consistent. Double. Now, if I try to do a lowercase double and call it my list equals new array list of type double, double, you're going to have a problem. Notice there's already a compiler error. If I hover over this, it says syntax error, insert dimensions to complete reference type. That's because it's very confused about what's going on here. The problem is actually that we should be using the wrapper class. Right? Okay, now you have a warning because you're not using it yet, but they're saying the value of the local variable is not used. That's fine. That's not an error. That's not an error. It's just a warning because we're not using it yet. Now we can use it because we have the capital D. So that's the wrapper class. So this right here, their example here and my example before, creates an instance salary list. Salary list is the reference variable which holds a reference to an array list object sitting on the heap, because the memory for this array list is, of course, since it's a reference type, it's an object value, object memory address that's returned, it has to be allocated at runtime. So that's our hint right there, is that it's dynamic memory, is that we have the new keyword right there. Essentially, every object that you want to create an instance of in Java, you have to use the new keyword. The notable exception, and only exception really that I can think of off the top of my head, prior to calling a, or not prior, but other than calling a method that returns an instance for you, ultimately they're going to call new on you. But built into the Java syntax is the string class. Obviously, if you say string, my string equals, and then in double quotes you put stuff, you don't necessarily need to use the new keyword. You don't have to say new string and then pass it the string you want to create in double quotes. So that's an exception, because strings are used so frequently, they wanted to make a syntax that was a little bit easier. But anyway, this right here creates an instance named salary list of ArrayList collection class. So it's an object. It's an ArrayList object reference. The elements in salary list must be of type of a reference to double. So the elements inside of here, not only is this overall thing, salary list, a reference to the overall array list, the array list has instances at each index, or will have instances at each index of doubles, double wrapper. What if salary list needs to be expanded? Well, unlike with regular arrays where you as the developer have to move the items over manually, the array list that's done automatically for you. What if you need to know the number of elements currently in a salary list? Well, instead of length, you're going to call size. Okay, there's no length property. You call the size method of the array list class. What if you want to insert an element at index 30 without destroying what is there? Well, you call the add method of salary list, and then you specify the index first, and then you specify what item you're adding. You could just put new double, and then in parentheses 40,000, 0.00. However, it's even easier to do this. Salary list.add 30, and then just put 40,000. But let's think about this for a second. This is the index. Okay, we expect it int there, but this right here should be an object. So how do we get around that? We're putting right here a double, correct? Because in Java, if you put a real number literal, meaning a number with an integer component, then a period, and then some sort of decimal component to it, Java automatically interprets it as a double. That's why when you try to create a float, you have to put F at the end of the literal to indicate I'm casting this to a float. So this is a double. This is not an object. This is a primitive. So why is this working? Well, this is called boxing. It's the automatic conversion of a primitive value to the appropriate wrapper object. So because it's a common test, Java allows you to do this. It automatically boxes it. When you take the data out, it's called unboxing. It's the automatic conversion of a wrapper object to the appropriate primitive type. Right? So that's pretty useful. So here's an example. When you want to get an element out, you call the get method and then pass the index. Even though this salary list is an array list and you call get on it, it will actually return the underlying double, which is the primitive of the double object at index 30. It's automatically unboxed. Now, we've talked about contiguous collection classes. Linked collection classes provide an alternative to contiguous collection classes. In a linked collection class, each element is stored in an entry object that also includes at least one reference to another entry object. So you can think of a linked structure like this. You have Missy, and then you have a reference, a field, that actually points to another object, and then that one points to another, and that one points to another, etc. The Java collection framework, or collections framework, consists of two hierarchies. In both of these hierarchies, there is an interface at the top and fully defined classes at the bottom. In between, there are abstract classes. Now, what are abstract classes? Well, these are classes that may have undefined methods, like an interface, as well as defined methods, like a regular class. They're somewhere in between a concrete class with fully defined methods and an interface which has no definitions whatsoever. It's just the method headers. But an abstract class can have these undefined methods, and they require that their subclasses, the classes that inherit from them, implement them. So here's the issue. Would it make sense that you can't create an instance of an abstract class? And that is the case. So let's take a look. Let's take an example here. There's an example in the book, and we'll do an example here. I'm going to say new class, and I'm going to create a class called parent. Okay, this is the parent. So for this one, I'm actually going to put the keyword abstract. As soon as you put the keyword abstract, you make it so that you cannot create an instance of this class. You can't create an instance of it. Now, you can have reference variables of this type, which allows you to do things polymorphically. I could say, for example, if I have a child class, I can say parent P equals new child, but I can't say parent P equals new parent. I will get a compiler error. So in this class, public abstract class parent, I'm going to put public string get prefix. What does prefix do? Well, prefix just returns a string that says I am. All right. And then I'm going to put public abstract string get class name. Now, notice I put a semicolon here. Now, normally you have to be very careful not to put semicolons after the headers of methods because you want to actually have a body. But in this case, this is an abstract method. If an abstract class has at least one abstract method, or if a class has at least one abstract method, that class needs to be abstract as well. Now, it makes sense that we can't instantiate a parent because what would happen if you called getClassName? There's no way to respond to it because there's no definition. So we'll say this is the end of our parent class. I'm going to create another class here, and for this one, I'm going to call it child1. Okay, child1. All right, so child1, in order to implement inheritance here with child1, you have to use the extends keyword. I'm going to say extends parent, and then inside of here, all I'm going to do is I'm going to implement the get class name. Parent, not parents, sorry. Okay, public string get class name. I'm going to return child1. Okay, end child1. All right, so there's our child1 class. Now what about, let's make another one, child2. I'm going to create a new class. We'll call this one child2. Notice you could also set the superclass here, but we'll do it manually just because it'll help us practice. So this one also extends parent, and you could put a bunch of other methods that have nothing to do with the parent because that's the whole idea behind inheritance is you can extend the capabilities. But right here we're just demonstrating that you can implement the abstract method that is defined, or not defined, but declared in the parent class. So this one, very simply, child2 just returns child2. Child1 returns child1. So we've got n child2 here. Okay, so we've got these three. Let's actually create a client. I'm going to create a class here, and I'll call it, we'll call it abstract test. All right, so we've got our abstract test. Since we're in the same package here, we can do public static void main. Notice the other ones did not have a main class, and as you know from your previous Java experience, you only put this in the class that should be the entry point. So let's do this. Parent P. All right, parent P. Then I'm going to say P equals new parent and see what happens. Well, you'll notice it immediately underlines it, and if I hover over it, it says cannot instantiate the type parent. Well, why can't you instantiate it? Well, remember what we said. If it's abstract, you can't create an instance of it. However, it allowed us to create a variable of type parent P, or of type parent. So what does that mean? That means that we have a reference type that can point to anything that is a parent type. So anything that inherits from parent is also a parent type. All right, so let's do this. I'll say new child1, and then I'll say parent P2 equals new child2. Right, so we got two different parent objects, P1 and P2. Oops, need the parentheses there. So we got these two objects here, and let's see what happens. System.out.println. We're going to say P, okay, the P information, P dot get prefix, and then we're going to put a space, and then P dot get class name. After that, I'm going to put another one, system.out.println. We'll say P2, P2 dot get prefix, P dot get class name. So when we run this, you might have the question, well, I'm really confused because get class name isn't defined in parent, but we're calling it on a parent reference type, a reference variable. This is actually okay because since the child classes are the actual objects we're pointing to, when it calls get class name, it waits until runtime to determine what the definition of the class is. That's because Java supports polymorphism by default because it implements dynamic binding. So when you hear the term dynamic binding, you might think, what does that term mean? And you might get it confused and think, well, how does that relate to polymorphism? I don't understand it. Well, we have inheritance going on because these child1 and child2 classes that we're creating instances of inherit from the parent type right here, parent. To make it a little more realistic, you might have like a dog and a cat type inheriting from an animal class that has generic things going on with it. So what actually happens when we talk about dynamic, usually when you hear the term dynamic, you're talking about something that happens at runtime as opposed to compile time. When we're dealing with the word binding, we're specifically talking about method binding. Now, what does that mean? Well, whenever you call a method, whether it's a constructor or well, constructors are special, but when you have like get class name or you have any type of method, whether it's defined in this class or another class, binding means how the method call is associated with the definition of the method. So how does it know which method to call? You see something similar when we have overloaded methods where you have methods with all the same name, but it determines out of context either by parameter or parameter and things like return type and stuff like that. When it determines that, it waits until runtime to do that too, because all method binding occurs at runtime. So we say that Java supports, by default, dynamic binding. In some languages like C++, since binding is static by default, it's done at compile time, you have to tell the compiler explicitly, I want you to wait until runtime to do the binding. And therefore, in languages like C++, you have to use the keyword virtual, okay, to say this function, which corresponds to a method in Java, this function is virtual. Wait until runtime to actually associate it. But in Java, we can still call them virtual methods, but we don't have to explicitly write the virtual keyword. So when I run this, let's run it. You'll notice that the first one says, I am child 1. Did we goof? Yeah, I goofed right here. That should be a 2 right there. Let's do it again. Sorry. There we go. So P says I am child 1. P2 says I am child 2, right? Because we call P2.get class name. Even though both of these are parent references, it's actually waiting until runtime, until we actually run, to associate with the appropriate objects method. So child 1's method returns child 2, or child 1. Child 2's method returns child 2. And the prefix is actually defined in parent. So it just returns I am. So that should be pretty straightforward. Interfaces are pretty straightforward too. They're basically, you don't really implement, or you don't really create an instance of an interface either, but you have types that implement the interface. So with an interface, you specify what methods that any class that implements this interface has to implement. So this is a generic interface called collection. The collection classes inherit, or rather implement this interface. So they have to have a size, they have to have isEmpty. These are things that you have to expect when you have anything that's a collection. So here's an example. We have an abstract class implementing the collection. So if I say public abstract class abstract collection implements collection. So you have some things like size, which may kind of depend on the implementation, so they further allow that to be postponed, the implementation postponed, until a concrete class can implement it. However, this abstract class chooses to implement the isEmpty, for example. The isEmpty is going to be if the size that's returned from this is equal to 0. That means it's empty. Size is 0. Pretty straightforward, makes sense. The benefit is that a subclass of abstract collection need not override isEmpty. It's already defined. The collection interface includes method headings for inserting, removing, and searching for an element in the collection. What if the application entails accessing all the elements in a collection? For example, maybe we want to print each employee whose gross pay is greater than $10,000. Or remove each club member who hasn't paid their dues this year. Or determine each student's grade point average. These are all possibilities if we have various classes, or various collections of objects and things we want to deal with. So how do we do this? How do we get through the class? How do we find our way around it? An iterator, okay, another term you should memorize and know. An iterator is an object that allows a user to loop through a collection object without accessing the object's fields. Let me say it again. An iterator is an object that allows a user to loop through a collection object, okay, that we've been talking about, collection objects, without accessing the object's fields. In other words, the fields, most often, are private. You can't directly access them. So how do we access them? Well, they provide an iterator. Iterators allow you to go through them. Associated with each class that implements collection interface, there is an iterator class that implements the following interface. So you have a collection interface, you also have a interface called iterator. Iterator requires that anything implementing it has to implement 3 different methods. You have Boolean, has next. You have next, which returns an instance of whatever the collection class ultimately is going to contain. And then you have a remove, which removes the element returned by the most recent call to next. To associate an iterator object with a collection, because you can create the iterator and then you create the collection, but how do we actually associate the two? You associate them by using the following method from the collection interface. You have a method called Iterator, and it returns, not surprisingly, an iterator of certain type of elements. For example, suppose we want to print the highest salary in the ArrayList object, salary list created earlier. ArrayList, as we know, is a collections class. So how do we iterate through it? So here's how you create the ArrayList. How do we actually get through it? Well, here's how you do it. You have iterator of type double because it has to match the type of salary list, and we're just calling it ITR. That's its identifier. You can name it whatever's useful and whatever makes sense. Equals SalaryList.iterator. This method automatically returns an instance of the iterator that allows you to iterate through this class. So we set double largest as -1 because we know it's all positive. This is always going to become the largest. You say itr.hasNext while that is true, because hasNext, remember, returns a Boolean, so it's either true or false. So we say while that is true, if it has a next element, you want to set double current equals itr next. That unboxes it automatically. So then we have the value at that particular location, and then say if the current is greater than the largest, then we set largest equal to the current. So this is basically a maximum method or a code segment that finds the largest or maximum salary in the entire group. So it doesn't matter if there's 100,000 items in here, it will find the largest because it starts with -1. We know the salary is not going to be, the salary is always going to be greater than that. So the first time through the loop, it will set the element to the first salary, and then if the second's larger, it'll set it to that. If the third's not as large, it'll skip the if statement. Then it'll keep going until it finds one larger, etc., etc. And then by the end of this loop, you will be able to print out the absolute largest in the entire array list. So in this example, and in most examples, all we want to do is access the elements. The only calls are to the iterator's hasNext and next methods. For such situations, there's an enhanced for loop. Okay, so the enhanced for statement or enhanced for loop is one you've probably encountered before. It allows you to very quickly and easily iterate through a particular set of elements. So for example here, again, we could do the same. This is the same code from earlier. It's just, or it does the same thing from earlier. It's just in using the enhanced for loop. So you've got for double current of type salary list, or from salary list in salary list. Current greater than largest. Current is an actual element. We're no longer dealing with indices at this point. We're dealing directly with the elements that live at different cells in salary list. It automatically does the bound checking, and it automatically unboxes. So it does pretty much the same thing that we did before. They give us an exercise, replace the following with enhanced for statements. The code first calculates average salary in salary list and then prints out the number of above average salaries. Assume salary list is non-empty. Okay, so let's look at this. I'm going to create another file here. Let me see, what's it about? Okay, we'll call it salary test. Okay, we need to import java.util.ArrayList to keep. Oops, sorry, did not mean to do that. That's a mess. Okay. All right, so we got that, and then we're going to do public static void main string args and main, and then in salary test class. Okay. So I'm going to create an array list of type double. We'll call it salary list, like they do in there, equals new array list type double, using the type parameter. Okay, good, we've created it. Now let's add a few salaries. Salary list dot add. I'm going to add, let's say 10,000, 10,000.0. Okay, salary list dot dot add 25 123 100. Salary list dot add we'll say 15,000. Salary list dot add 45,000 salary list dot add 35,000. Okay, so we've got a few items in our list to deal with, but really we could make it fairly large, arbitrarily large. So right here, if I move this guy over there, and maybe move this guy over here, we can look at the slide on this side and look at our code on this side. We can see that what we're doing here is we're trying to find the, I guess they're finding the number of above average salaries. But, we'll make it a little bit, yeah, I guess we can do that. That's fine. Number of above average salaries. So they're finding the average by taking the sum, after you find the sum, and then doing the salary list dot size. So what we're going to do is we're going to find above average salaries. Well, first of all, I'm going to write two different methods here. I'm going to say public static void called regular while. And then I'm going to have public static void enhanced for. Okay, so for this one we're going to use the code that they have. You have a sum, you create an iterator, itr equals salary list dot iterator. Right? It can't find iterator, so we have to import java.util.iterator, something I forgot earlier. And, oops, salary list has to be passed in. So let's give this a parameter here, or we can make it global, or well, not really global, but a field. But I'd rather just do this. Array double salary list. Okay, oops. So we'll do that. Let's see if it's angry. Array list, there we go. Array list. All right, so I'm happy. Right here. What is it angry about? Okay, I need to complete local variable. Oh, equals. Sorry. All right. So you've got the double iterator there. We also have to remember to pass our array list down here also when we use it. So this one's going to use the traditional while loop method, which we see over here in the slides. So I'm going to have while itr.hasNext. While that is the case, I don't like the fact that they're not putting curly braces. They're probably doing it just to save space on the slides, but I prefer if you do it this way with slides or with curly braces. Double average equals sum divided by salary list.size. Right, so that'll find the average. And now we're going to count the number that are above the average. So we have a count equals 0. So we just found the average, and now we're going to say itr equals salary list. Oh, we already found that is the salary list dot iterate. I think we have to start over, yeah. Iterator. Okay, and now we're going to say while itr dot has next. Yeah, the reason we have to do that is because if you keep going and you don't reset it here, it's going to start where it left off, which is the end, and that's bad. Okay, so we've got itr.hasNext. If itr.next, the next element that we find, is greater than the average, then we're just going to increment count. So we're going to find the number that has greater than that. So that's pretty interesting. We've got this. I'm going to put system.out.println, and I'll say average, the number of above average salaries is, and then put count at the end. Okay, so I'm going to try this and see what we do, what we have here. So I'm going to call regular while, which is the name of my method here. I'm going to pass it salary list. So regular while, and I'm going to run it, see what happens. It says number of above average salaries is 2. Okay, I'll take your word for it. We could go through and verify it, but we gotta. What we want to do is we want to see if the enhanced for loop version that we're going to write returns the same thing. So with an enhanced for loop version, we're going to still have the sum, right? We don't need to explicitly use an iterator though. We're going to say for, since they're doubles, we're going to say for double D in salary list, right? So we have a double living in there. We're going to take sum plus equals D, right? And then double average, sum divided by salary list dot size, same thing as before. And because remember, our exercise was to convert this to an enhanced for loop version. Int count equals 0. We don't need to do the iterator again. We're going to use the enhanced for loop. We're going to say for double D inside salary list if inside here we find that the D is greater than the average, we're going to increment count. Right? So at the end of this, the end of the enhanced for method, we're going to put system.out.println, say number, same thing, number of above average salaries is, and then same thing, count. So let's call it up here again. Put a little space in first. Then I'm going to call enhanced for, pass it salary list, and see if we get the same answer. And indeed we do. Right? So they match. We could actually copy a couple of these and just modify them slightly, maybe. 47 and 37. 37. Okay, and then we'll run it again and see what happens. Okay, now there's 4 above, but you'll notice they're both getting the same value because they both essentially do the same thing. You'll notice that the amount of code we did down here was actually less, though, using the enhanced for loop. So it's pretty interesting. All right, so let's go on. The collection interface has method headings for inserting, removing, and searching, and a few other methods such as size, is empty, to array, etc. The list interface extends the collection interface by including some index-oriented methods. So you have public interface list, remember, because interfaces can extend other interfaces. They don't implement them, obviously. They're extending them. So you have interface extends whatever the other interface is, returns the element at the position. You have get, set, add, and remove. Also index of. So the framework has 3 implementations of the list interface. The collections framework, Java Collections Framework, JCF, has 3 implementations of this list interface we just learned about. So we have ArrayList, which we focus on in Chapter 6, LinkedList, which we focus on Chapter 7, and we also have Stack, which is in Chapter 8. So here's an example. Create an array list of strings, add some names to it, last names. If you call system.out.println just on my list, it automatically has an overload of toString method, so it will print out the whole list. System.out.println, you have mylist.get at 2. That'll get the element at 2. You can set the element at 3. Add an element at 4. Set actually overrides whatever's in that position, whereas add will actually put an element at that position, scooting all the other ones over. And remove removes elements. Again, you can also use index of. You can find an element in there, you pass it an instance of the element, compare them. Then they use an enhanced for loop at the bottom, and it says string name in my list. If the name starts with, basically you're saying name.char at 0, that means if the name has its first character as a capital C, they want to print it out. Otherwise you apparently ignore it. Linked list example. Okay, this is another implementation of the list. You have linked list, same situation here. Pretty much exact code. In general, an array list object is faster than the linked list object when the application frequently needs to access elements at specific indexes or indices. You might ask why? Well, that's because the random access of the underlying array. Arrays are random access. The memory is contiguous. With a linked structure, which we'll learn about more, these structures have, remember, as their fields, memory addresses or reference variables to other objects of the same type, the entries. Remember, they're like nodes in the list. The linked list object is faster when the application entails iterating through the object and often performing insertions or removals during the iteration. So with an array list implementation, the other type, the contiguous list, you have to actually move all the items over to make room and then add the item. However, with linked list, you find the place where you want to add it, and you create a new node, and then you just set a couple reference variables, like you set the new item's reference variable to the rest of the list, and then set the one previous to that new item, and then you've just quickly inserted an item into the list. So they say why? At a given index, an element can be inserted or removed without moving any of the other elements. So you're not moving them. They're not contiguous memory. They're floating all around the heap, but they're connected by the fields that have the connections. So here's an example here. You have the collection interface. This is a UML diagram, very colorful one apparently. UML class diagram. You have the interface collection. You also have list and set, which inherit from interface, inherit from collection. In interface, you have abstract list, which implements the list, and then you have abstract set implements the set, or not all of it because it waits for the concrete classes to do some of it. But array list, linked list, and stack come from abstract class, or abstract list, I'm sorry. And then tree set and hash set come from abstract set. Also, you have map, which we didn't see before. That is an interface. You have abstract map, and then you have tree map and hash map. So just be aware that these are available. Go through the examples, some of the examples in the book, and maybe review some of the examples I've done. Make sure they work for you. Everything makes sense for you. And that's it for this week. So go through the slides, make sure you're comfortable with the material. If you have any questions, please email me or post in the discussion boards. Thank you very much and have a great day. Goodbye.